Hello, welcome back once again, friends. Well, after a long time I'm making these videos. I'm extremely sorry for the gap. I hope now I can continue properly. Well, today I have come with some basic techniques, right, that we have to use while finding the derivative of any functions. Well, there are many methods, many techniques we have to use while finding the derivative of functions. A function can be anything. It may be trigonometric function, maybe algebraic function, maybe logarithm function, any kind of question maybe it is, right? But I feel like these are some basic techniques, these first principle method, power rule, sum rule, product rule, quotient rule, and the chain rule. Actually, we have discussed these all things. And once again, I just want to sum up this all. I just want to make a review video, so that's why I try to make this video. And after learning this, I'm planning to make dozens of videos for each methods, and some kinds of a little bit higher levels derivative will also find out, right? I mean, a little bit difficult problems will also find out. Well, let's talk first. The first one is, the first principle method, I said. Well, if you're remembering, whenever we used to have a function, something like f of x, we have a function something like you can say 3x square plus 1, you can say, right? This is our function. Some people also write like this, in the place of f of x, y equals to 3x square plus 1. So actually both are same, so don't confuse, right? In these types, if you have a function, then how is to find out the derivative by the first principle method? I just want to quickly do it. You know that we used to make a small increment is x as well as y. Actually derivative is just a ratio of the change in derivative, like change in y-axis over the change in x-axis when delta x tends to 0, right? So, well, I hope you know very well the definition of derivative. So I'm just making a small change in y as well as in x. All right, so y plus delta y, and similarly in x also a small change is going to be there, x plus delta x whole square plus 1. And then we used to shift this y to right side, then I can write delta y equals to 3x square plus 2x delta x plus delta x whole square, right? I just explored this by using formula a plus b whole square, that is a square plus 2b plus b square, and then plus 1, and then minus, right, this y part. And then again what I can write delta y equals to 3x square plus 2x, and this 3 and this 2 will multiply, so it will be 6x times delta x, and then 3 times delta x whole square plus 1. And then in the place of y I can use this, actually y is 3x square plus 1, so I'm just putting here 3x square and plus 1 it is, so here is minus, that's why I'm writing here minus 1. Now I'm sure there will be some cancelling parts. See here, minus 3x square and plus 3x square, similarly minus 1 and plus 1 will cancel out, and now we are left with few things, that is delta y is equal with now actually 6x times delta x plus 3 times delta x whole square. I think I can take the common from here, right? We used to, every time, I know I think you're remembering, every time we used to take the delta x common, so delta x is getting common here, so that's how we're getting 6x plus delta x here. Now after this step, every time what we used to do, we used to divide both sides, left hand side, this left hand side as well as this right hand side, by the delta x, and we have to take the limit. So I'm dividing this side also, delta y over delta x, I divide here this side by delta x, and this side also I'm going to divide by the delta x. So delta x 6x plus delta x, and I divide by the delta x this side also. Now what I'm doing, I'm going to take the limit both side. Limit I'm taking, right, as a delta x tends to 0. So this side also I'm taking limit as delta x tends to 0. So now see what I'm going to get. I'm going to cancel out this, right? And this limit when delta x tends to 0, delta y over the delta x is actually the derivative of function y with respect to x, or you can write like f prime of x equals to 6x, and in the place of delta x now it will be 0, so it will be simply 6x. So 6x is our derivative, this method, like in this method if you are finding out the derivative, this is called first principle method. But people are using very shortcut to find out the derivative by first principle method, also by using the shortcut, shortest one you can say, directly using the formula. Like derivative of a function f of x is actually limit when delta h tends to 0, f of x plus h minus f of x whole divided by h. This shortcut formula you can say we might have used, yeah, we have used in many of the videos, in initial videos, to find out the derivative. This, if you can directly plug the value here, h is actually a small change in x, or you can say in the here in this place many many books is to write delta x also, right? So if I'm writing here x plus delta x or x plus s, that's the same thing. H, you just understand there is a small change in x, a small increment, maybe decreasement, whatever it is, right, in x. All right, so you can easily find out the derivative of this here also. So it will be simply like x plus h it is. So like you just make a small change here, right? And you can easily find out. That's not the way. So this was our actually first principle method, or you can say definition method. And the second method was our power rule. Let's talk about the second method. And in power rule, what we have learned, if we have a function f of x equals to something like x in the power n, then the derivative of this function f of x is actually power times x to the power n minus 1 times derivative of the base whatever we had, whose power is actually n, divided by dx. And finally what we are going to get, both are same, so we were getting n times x to the power n minus 1. And this was actually power rule. And if you're finding out the derivative by using this rule, then that we can say that a derivative finding by the power rule. So simple, I'm giving a good example here. Suppose I have a function y equals to f of x, also you can write y equals to also, right, that same thing. Let me say this is 3x square plus 2 whole to the power 4, right? So in this case what I have to find out, derivative, right? So dy by dx, or you can say derivative of the y with respect to x, is now, see, power rule. As I said, what is my power here? Power is n and here is 4. So first I'm writing 4, and then whatever the base I do have, that is x, and in the place of x we have here now 3x square plus 2. So 3x square plus 2 whole to the power, what if in the power there will be 1 less, right? So 4 minus 1 less, and then times derivative of the base whatever we have with respect to x, right? So our base is 3x square plus 2 whole divided by delta x. And finally we're going to get like 4 times 3x square plus 2 whole divided by, sorry, whole to the power 3 times, now derivative of this function will be what, 3 to the 6, right? 2 minus 1, that will be 1, so I don't have to write. Like derivative of 3x square plus 2, you have already found out, that is 6x, so that's why I'm writing here directly 6x. All right, here also actually I have used the power rule here also, simply in a short way I have used. Let me show you just how I had find out the derivative by using power rule here. Like our function is here y equals to 3x square plus 2, right? And therefore dy by dx, I mean to say derivative is, this is the constant, so I need to put outside, right? And what is the power is here, 2. So power times whatever the base, and we need to raise the power less 1, right? 1 less we need to raise. So initially power we had 2 here, so there will be now 1 less times dx by dx. But generally people don't write this, and actually they're gonna cancel out, so that's why directly you can write 6x also. But you need to do a lot of practice. Once you get perfection, so you can directly write, you don't have to do these all steps directly. Like find out the derivative of y equals to 3x square plus 2, then that time you can easily do like dy by dx equals to 6x. But for that, you need to do a lot of practice, and I hope you're doing good. All right, so this was all power rule, and the next rule is sum rule. All right, so the third one, let's talk about sum rule. In sum rule, suppose I have a function h of x equals to f of x plus another function g of x. If two functions are going to be added or subtracted, that doesn't affect. So how to find out the derivative of this now, h of x, these functions? So for this, nothing is there, simply derivative of the h of x is actually derivative of the first function plus derivative of the second function, right? So first find out derivative of the first function and then plus minus derivative of the second function. Already that, like writing here prime means derivative is that. And for that I just want to give a very quick simple example. Well, suppose I have a function y equals to 3x square. So fx is actually 3x square, and gx you can say, let me give x to the power 5. Well, I need to write this x to the power 5 first and 3x square later. Well, no problem. So now derivative of this function y, simply you can say like dy by dx is, now I'm again using the power rule, the same method. I just want to tell you what is the method, right? So first I need to find out the derivative of this thing, right? This is a constant, it will come outside. So x to the power 2, I'm using the power rule, power times base and 1 less in power. And dx by dx, like here will be derivative of, here will be actually dx by dx. So I don't think I need to write it, all right, but it is initial stage, so that's why I'm writing. Well, now again I find out the derivative of this. Actually, if f of x I already find out here. Now I'm going to just find out the derivative of x to the power 5. So again I'm using power rule, that is power times whatever the base I do have, just I need to make in power 1 less. So 5 minus 1 times again dx by dx. We don't have to write these things actually. You can cancel. If you don't want to write, don't write. Nobody will say you anything, because everybody know dx by dx is 1, right? So 3 times 2, that is 6x, and 2 minus 1 we don't have to write. Now 5 and x to the power 4, right? So this is actually a simple sum rule. Sum rules mean, it's simple, like if two or more than two functions are going to be added. I just like I had imagined here like f of x is a function which is 3x square, and g of x is another function which is actually x to the power 5, right? So in that case these two functions are going to be added here. Here maybe minus or plus, that doesn't affect, I already told you, right? So this was our sum rule, and now we are going to learn about, I think, product rule. Well, this is a little bit important, so let's talk here product rule. So what is product rule? You know very well, like I have a function like y equals to, suppose function f of x and g of x. I don't want to write this at y. Let me say this is h of x, right? This is x. H of x is another function which is the product of actually two functions, f of x and g of x. So in that case, how you will find out the derivative of this? Well, let me take an example. Now first let me write the formula what we used to do. Actually, derivative of the function h of x will be first function times derivative of the second function, again derivative of the first function times second function, right? Many people write like this also, like if you have something like y equals to u and v, represent here u and v are representing one individual functions. So that time derivative of this function will be first function times derivative of the second function with respect to x, right? And again second function times derivative of the first function with respect to x, right? When you're taking first function, derivative will be second function. When you're taking second function, derivative will be of the first function, right? So that's another problem. It's very easy to quickly remind, you can say like derivative of the function y, to quickly remind, this is another formula. Well, to remind u dv, right? You can imagine like udv and vdu, right? udv video, udv and video, u here representing one function and dv means derivative of the function v, and here is v, right? This is v. Well, it's very dirty. This is v and this is derivative of u. And even short, if you want to understand, then you can say u audio minus video, right? vdu video, au dv audio, something like, you can say audio plus video, right? Audio plus video, like something like this. I used to remember something like this. Well, you can remember in any ways, simple it is. But let me give you a simple example here, right? Suppose example, let me give you here. uh, Suppose I have a function y equals to 3x square times, right? This u is one function which is 3x square, or you can say fx is one function which is 3x square, and another function, let me take x uh, plus 1. Alright, x plus 1. This is another function. This gx is actually x plus 1. So two function is going to multiply here. So now how to find the derivative of this? So to find out the derivative of this, simply dy by dx. As I said, write first function, right? Write first function, then find the derivative of the second function. So I'm writing first function and I'm going to find out the derivative of the second function, x plus 1. Alright, and then again write second function, find the derivative of the first function. So I'm writing second function and going to find out the derivative of first function, d by d 3x square over dx. So now 3x square is 3x square, and see x derivative of x, now you can use your sum rule. First derivative of x dx by dx, that is 1, and derivative of a constant, that is 1 is a constant, derivative of constant is actually 0, right? And again x plus 1, and here 3 is a 3 is actually a constant coefficient, so it will come outside, and x square it is, right? X square, so derivative of x square is 2 times x to the power 2 minus 1, right? 2 minus 1. So finally what I'm getting 3x square plus 3 to the 6x, and in the bracket x plus 1. You can open it also, 3x square plus 6x square plus 6x. Finally I'm going to get like 6 plus 3, 9x square plus 6x. This is my derivative, right? Using using product rule. And after that we had learned another rule, that is it's I think fifth, quotient rule, right? So what is quotient rule? Well, quotient, like something like two function we have in the like dividing form. Like I have a function f of x which is going to be divided by g of x, another function, and now here is another function h of x. So h of x is, I have a function which is actually the uh, one function divided by another function, right? So in such cases, how to find out the derivative of this function? So we had learned the rule. Actually I'm revising these all things, I know you might be knowing, just I'm reviewing it all, right? So it is simple. Second function, right? Second function times well, how bad it is looking. Second function times, I'm talking about, this is my second function, this is my first function, okay? So second function times derivative of the first function minus first function times derivative of second function, and then whole divided by square of the second function, square of the second function, or in the form of u and v if you want to see. I feel easier there, I don't know why. Well, I have a function u and v, suppose. So what will be my derivative now? So my derivative is going to be v times derivative of the u, and again sorry, here will be minus, right? U times derivative of v, means second function, divided by v square. Okay, so v du minus u dv divided by v square. So v du, now you can say video minus u dv, audio over v square, video minus audio over v square, video square, something like that. All right, well, this is just a trick, how you want to remember. It may be crap, someone maybe some people you may not like, right? Well, this was my way of learning, leave it. Well, so simply v du du over dx and u dv over dx, because I'm going to differentiate with respect to x, right? That's why this is the formula. So I'm going to give a very simple example here, very simple, right? What should I give? Well, suppose I have a function y equals to 3x square over 2x plus 1. Alright, so here 3x square is representing function u, or you can say fx, and 2x plus 1 is representing function gx, or you can say v. Alright, so now we have to find out the derivative of this. So therefore what I will write now, that derivative of the function y with respect to x is equals to, again, second function as it is written here, right? Second function 2x plus 1 times derivative of the first function d by dx of 3x square. Alright, and then minus see a u, that is first function, right? 3x square times derivative of the second function, that is 2x plus 1. Well, let me shift a little bit. Well, now whole divided by now square of the second function, or you can say the square of the denominator. Alright, so now what I will get, I will get my derivative as, now 2x plus 1 it is, right? 2x plus 1 times, now derivative of 3x square is actually 6x, now your export, I know that, and 3x square, it is 3x square, and derivative of 2x is just like see coefficient, and derivative of x will be 1 and derivative of 1 will be 0, so I'm not writing those things. Alright, and whole divided by 2x plus 1 whole square, and now you can you can multiply and you can solve this expression, and finally you'll get derivative. Alright, so I was just talking about the rule or technique what we had used, and further what we are going to use. Now the last one I just want to tell you here, that is called chain rule, right? The sixth one, and it is also very important rule that really plays a very important part while solving derivative. It's called chain rule. So what is chain rule? So chain rule is a little bit different than other as we have learned, because in here in one function other function get attached, get enclosed. Suppose I have a function something like y equals to f of u, see here, where where actually u is also another function something like g of x. So in that time how to find out the derivative, so actually we had learned like it is something, if we have such condition, then dy by dx will be actually derivative of the function, derivative of y with respect to u, right? Derivative of y, derivative of function y with respect to u times derivative of function u with respect to x, with respect to this x. Try to catch it. So in this way actually we used to find out, and finally what happens, actually you're gonna cancel a lot of things here and you'll get the result finally. And you can simply also say like this is dy by du, or you can say like du by dx, dy by du, if you say like it's actually just function, this, if you in the place of this you can write also like something like derivative of the first function times du by dx. It will be a little bit ununderstandable. Let me take a good example. Suppose I have a function, well, let me think. Suppose y equals to 4u square, this is right, 4u square minus 3u plus 5. Suppose this is my function, and I told you like here y equals to 4u square minus 3u plus 5, and u is itself another function, right? So let me suppose here u is actually you can take anything like 2x square minus 3. Now how to find out the derivative of this? So I already told you, in this condition to find out the derivative we have to say dy by dx is actually, now see here I'm just going to write dy by dx first, dy by dx, sorry, dy by, I'm just first going to write derivative of y, this function, right? Or you can say this function with respect to u, see, with respect to u times, again derivative of u, now derivative of u with respect to this x, with respect to this x, right? Same thing how I'm doing, let's check it out. Now dy by dx, so derivative of y, that is what, 4u square minus 3u plus 5 whole divided by du, okay, du, again times, right, derivative of u with respect to x, so derivative of 2x square minus 3 with respect to x. Now see what we're going to get finally here, 4u square with respect to u, so it will be, now power rule I can use, so 4 times 2, that will be 8u minus derivative of 3u, it will be, since 3 is a coefficient, so it will be 3u, and again you'll get du over du, right? So I'm not going to write, well, if you want then you can write also, and derivative of f is of derivative of this 5 is actually 0, because 5 is a constant, right? Times, now see what you're going to get, 2x square minus 3. So 2 times 2, actually power rule I'm going to apply since this is 2, right? So 2 times 2, it will be 4u, 2 minus 1, and this derivative of 3 is actually it's you can say a constant, so that will be 0, so I am not going to write now here. Now what do you get finally? 8u times 4u. So finally I'm just going to multiply this. 4u will multiply this whole part, right? So 8u times 4u, it will be 32 u square minus again this 4u will multiply this 3, so you'll get 12u, and let's put the value of u. That's it. And the value of u have got here 2x square minus 3, so it is 32, right? 2x square minus 3, right? We finish this part, and then plus this is square, and then it is minus 12u. 12u is what? 2x square minus 3. 2x square minus 3. And by solving this, just solve it up and we'll get the answer. That's it. This was just a method, to find out the derivative. So I hope you understand these basic concepts, and we'll be doing more and more problems that will definitely give you more concepts. And I just want to say, just quick review these all whatever we learned now, and after that we'll be doing a lot of problem one by one, step by step I'll be doing, right? Please try to watch and try to do yourself. After that, after watching, just write the question and try to do yourself. I'm sure you can solve the problems and you'll be perfect in derivative. Okay, so we'll be meeting in the next video. Bye bye, thanks for watching.